Welcome back to my channel. So in this video we're going to learn about the next chapter, that is thermodynamics. And in this first part of video we're going to learn only some basic concepts of thermodynamics. Thermodynamics is the branch of chemistry which deals with the interconversion of various forms of energy. And it also gives the feasibility of the reaction, but it cannot give the rate of the reaction. The next term we are going to learn about is system. Anything which is real in universe and is under observation is called system. So example is the gas present in room, water in the water bottle. So if you take one example, so if you take one beaker which is full of water, then this beaker is called system, and around it everything is called surrounding, which you are going to learn of. So surrounding is the remaining part of universe other than system. So we can say that universe is equal to system plus surrounding. We know that everything apart system is called surroundings, then system plus surroundings equals to universe. Now we are going to learn about the term boundary. Any real or imaginary, rigid or non-rigid surface that separates system and surroundings is called boundary. So we have taken one example here. If you see, this is surrounding and this is system. So if you can see, the surface of this beaker is the boundary. It separates system and surroundings. So this is called boundary. And boundary can be real, imaginary, non-rigid, rigid and flexible. So now we are going to learn about different types of boundaries. The first type of boundary is real boundary. So real boundary is the clear separation between system and surroundings. So if you take one example, so this is the beaker which contains water and around it is the surroundings. So here the surface of the beaker is the clear separation, that is, it's a real boundary between the system and surroundings. And next one is the imaginary boundary. Imaginary boundary. So if there is no clear separation between system and surroundings, then it's known as imaginary boundary. So if we can take one example, like so here is one beaker containing water. Sorry, let's take another one. And here is the gas particles. So here if you see, there is no clear separation between the gas molecules and the water. So the boundary between this gas molecules and the water is known as imaginary boundary. It is known as imaginary boundary. The next type of boundary which we are going to learn about is rigid boundary, which is also called fixed boundary. So the boundary which doesn't move and is fixed is known as rigid boundary. So if we take one example, so here is one book placed on the table. Here is one book placed on the table. So whatever it may happen, but the volume of the book doesn't change. That means that the boundary doesn't change. This is all surroundings and this is the system. So the outline of the book doesn't change. So the boundary is fixed. So it is called rigid boundary. And in rigid boundary, there is no compression, there is no expansion, and there is no change in volume. Okay, so we can say that delta V, that is delta volume, is equal to 0 and delta P is equal to 0. V means volume, P means pressure. Because there is no change in volume, delta V is equals to 0, and there is no exchange in pressure from system to surroundings. So delta P is also equal to 0. The next type of boundary which we are going to learn about is non-rigid boundary. The boundary which doesn't move and is fixed is known as non-rigid boundary. So we can say that there is change in volume because the boundary is movable. So delta V is not equal to 0. So if you take one example like, so if you take one beaker which is kept under a tap. Actually my drawings are not that good, so please just adjust. It is kept under the beaker. So here if you see, the level of water will increase with the time. So we can say that the boundary between the boundary level is increasing. That means the boundary is not fixed, the boundary is movable. So we can say that there is exchange in pressure and there is change in volume also. And if the pressure exerted is greater than pressure of system, it means it is compressed. But if P external is less than P system, then it means that it is expanded. These are the two important points which we will learn later also, but just to give an idea I will be telling them. Okay. The next type of boundary is diathermic boundary. The boundary which allows heat to exchange is called diathermic boundary. So actually it allows, the boundary which allows the heat to exchange between the system and surroundings is called diathermic boundary. So we can say that exchange in heat energy will not be 0 because there is some heat of exchange in heat energy. Now we are going to learn about adiabatic boundary. The boundary which doesn't allow heat to exchange from system to surrounding is called adiabatic boundary. So it allows heat to exchange. So we can say that exchange in heat energy is not equal to 0 and it doesn't allow any matter to exchange from heat from system to surrounding. So we can say that exchange in mass is also equal to 0. So after completing the types of boundary, now we are going to learn about the types of systems. The first type of system we are going to learn about is open system. The system in which there is exchange in mass and energy between system and surroundings is called an open system. So if we take one example, so you take a beaker containing water and get it heated for some time, and you'll observe some vapors coming out of the system. So we know now, we can clearly see that there is exchange in heat, that is there is exchange in energy, and the mass will also decrease with increase in time because the water changes into water vapor. So we can say that it is an open system. By this we can write as exchange in heat energy, exchange of heat energy is not equal to 0, and exchange of mass is also not equal to 0. Okay. Now we'll move up into next type of system. The next type of system is closed system. The system in which there is exchange in energy but no exchange in mass is called closed system. So we can say that exchange in heat energy is not equal to 0, but exchange in mass is equal to 0. So if we take one example, so we will take one beaker containing water and it is heated for some while, but we'll close it with a cap. We'll close it with any utensil or what. Okay, then if it is heated with a lid closed on it, the energy transforms from system to surroundings, but the mass remains same because the vapor will not go outside the system. So this is one example of closed system. The next type of system is isolated system. The system which do not allow mass and energy to exchange is called isolated system. So as there is no exchange in mass and energy, exchange in energy is equal to 0. Exchange of mass is also equal to 0. So if you observe, the isolated system is same as the adiabatic system, because in adiabatic boundary also the boundary doesn't allow heat and mass to exchange. So adiabatic boundary and isolated system are both alike. Thanks for watching this video. Please do like, share, comment and subscribe to my channel, and please do click on the notification bell icon so that you can get updates of my new videos. And in the next video, we're gonna learn about intensive and extensive properties, state of system, state function and path function, and other more topics. Till then, bye-bye.